Now, so hello and welcome to everybody to this panel discussion on digital twins. My name is James Candon. I'm Managing Director of United Europe, and we are based in Germany and in Brussels in Belgium. I'm delighted to have this opportunity to host a discussion which is part of the 15th International Conference on Digital Society, which is happening in real life in Nice and in digital twin life here online in virtual reality. I myself are currently sitting on an island near Dubrovnik. Let me just tell you about Europe. It's a non-profit association with the goal of promoting the diversity, competitiveness and unity of Europe. And with that in mind, I'm delighted to welcome a very, very diverse panel. We have Olga Levina from TH Brandenburg in Germany. We have Mohammed Kassem from the University of Northumbria in Newcastle in the UK. We have Lasse Berntsen from the University of Southeastern Norway, and Camilla Shiveran from the University of Cambridge in the UK, and in Italy. She seems to be based in both that University of Cambridge and the University of Campania, Luigi Vanvitelli. And finally, last but not least, Jean-Pierre Toumazet from the University of Clermont-Auvergne in France. If each of you could briefly, starting with Lasse, then Mohammed, then Olga, Camilla and Jean-Pierre, if you could each give me a little bit of background about your own biography and particularly bearing in mind its relevance to the subject matter that we're discussing now, which is digital twins.
Yes, I'm happy to start, and I'm Lasse Berntsen. I'm a professor in information systems at the University of Southeastern Norway. I do research on smart cities, smart grids, and autonomous systems. And I'm also teaching Internet of Things and business analytics. And the subjects I'm teaching is very, very relevant for digital twins. We have used the concept of digital twins in our IoT teaching for the last 3-4 years. And we also had several students doing assignments in this area. So I'm very happy to be here on the panel and share some of the experience we have in this area.
Much obliged, Lasse. And in case anyone's wondering, the order of choice just happens to be random. The digital twin of Zoom has posted Lasse first. Mohammed, you're up next.
Thank you very much. Hi, everyone. I am Mohammed Kassem. I am a professor of digital construction and engineering at Northumbria University in Newcastle. I also lead a research group here called Digital Built Environment, and I chair a committee in Europe called HDI, Human Data Interaction. I've been doing research on digitalization, mainly within the construction industry for about 12 years and more. And I'm representing here as well the RINO H2020 project, which is looking as in good part is looking at digitalization and through digital twin basically of site operation, but also building operation. Thank you very much.
Thank you, Mohammed Kassem. Olga Levina, can you tell us about yourself?
Yes, of course. Thanks for inviting me, and thanks for this introduction. So I'm professor for business process management at the TH Brandenburg University of Applied Science in Brandenburg. And I am teaching, well, business process management, business modeling, and my research is about digital platforms and ethical and social aspects of digitization. So I'm representing here the business modeling part and the social questions of system analysis and system design.
Excellent. Thank you, Olga. Camilla Civeran.
Yes, thank you all for inviting me. And I am Camilla Civeran. I am an architect and a PhD student in environment design and innovation at the University of Campania, but also collaborating with the Inclusive Design Group at the University of Cambridge, Department of Engineering. I currently study new inclusive multisensory models for knowledge sharing and for the enjoyment of cultural heritage. And I could say that digital twins were actually often part of my studies and my professional developments, even if not under this term, which I only discovered recently. As far as I'm concerned, the advancement of technologies going in this direction has actually an important potential to improve the way that we imagine concepts and we understand architecture and cultural heritage, and the way we conserve and build it, since it gives the opportunity to also see somehow otherwise invisible details, for example, of the cultural heritage. So this is why I'm here. Thank you very much.
Thank you, Camilla. I'm personally very interested to hear more about how digital twins let us learn more about our cultural heritage. It's one of the questions that will come up later on, and how we can conserve as well artifacts for future generations. Jean-Pierre Toumazat, last but not least, could you tell us a little about yourself?
Thank you very much for inviting me. So I'm an associate professor at the Clermont-Ferrand University in France. My field of interest for teaching is electrical hazard. One of these fields is electrical hazard. And so I'm not really an expert of digital twins, but I have conducted an original experiment to build a digital twin for training of students in electrical risk. So it's the reason of my participation to this event. The principle consisted in creating a digital twins of an electrical cabinet in partnership with a company specialized in virtual reality and involving the students, the future user. So it's quite a new way of teaching this type of works, and it's why I'm here now for this presentation. Thank you.
Super, Jean-Pierre, and it may come as a surprise, but guess what? I also am not an expert on digital twins or anything very much digital. So I'm here to learn just as much as you, although I suspect you have a bit of a head start on me. So let's get the discussion started, and we'll start with the first question around about this whole concept of digital twins. Let's go back to basics, first principles. Is it a new concept, or is it something, an innovation that has been rebanded from the past? I will designate someone first. I'd like each of you to answer. Perhaps Olga, you could maybe jump in, and then the others can follow if you just put up your hands, each one, afterwards.
Thanks. Yeah, that's a perfect question for me, since I view the digital twins as a models, so as extended models. So for me, it's not such an innovation. It's just an extension, well, quite a big one, of existing concepts, such as, business processes and the systems analysis aspects play a role here, and users are being presented in more detail, and of course with more data affected, and across sectional communication and cooperation are represented. So this is a huge model for me, fed with a lot of data that is being processed, but it's still a model. So I would say the model theory apply, and we're still dealing with basically classic approach, but with a lot of power behind it now.
Thank you very much, Olga. Mohammed, could you maybe follow up and give some details to your view on that and how it helps in the real-life business of construction?
Yeah, thank you. I think it's interesting that to have a mixed panel from different backgrounds, similarly the audience. I think in construction there is something even more challenging that makes the emergence of digital twin much more challenging. And many from construction background are really blaming digital twin for causing a little bit of confusion, and they are considering it as a trying to rebrand something that currently has been in the industry for about 15 years, which we call it building information modeling. It is really difficult. It is really a difficult debate. If you look at facts rather than my opinion, you go to LinkedIn or Twitter and you try to see the position of expert around this, you find three categories. Some that are really unconvinced, that say This is a rebranding of digitalization effort that's already there within the industry. Some they are saying, no, this is actually a new innovation. Let's all align ourselves and push it forward. And there is in between some people who are undecided. They don't sit in any of the previous two positions. They say, okay, hang on, let's look at it. Let's look at it. What's new about it? So if you really go deeper, I'm writing a peer-reviewed paper on this. If you look deeper into this problem, you will realize there isn't a clear definition of digital twin. There isn't a clear agreement, but there are certain agreement on certain characteristics. You know, the fact there is a physical world, a digital world, the fact that there is a dual, you know, a two-way connection between the two. So that's where the agreement is heading. There is still disagreement about whether we need a digital model, like in terms as we know it, like 3D model, or as long as we reflect the behavior of the physical asset in a cyber world, that's still considered digital twin without the need of a digital model. So there is still lots of debate. I don't think there is, it has been proven, or there is no clear position. And in the meantime, it's causing lots of issues for research students because lots of people are labeling their papers within academia as digital twin, and lots of industry products are being labeled as digital twin. So when you send a research student to find a paper on digital twin, they get something, but doesn't have anything digital twin about it. So there are quite a lot of issues, but we are, I think, if we agree on a definition between the industry and academia and on a certain characteristic, we would resolve, because digital twin, I think, it has its own characteristic, it has its own application in the future, but we need to agree on those better in a clearer way.
Thank you, Mohammed. I'm beginning to detect that there's the potential for an academic argument purely on the definition, but we won't get drawn into it. But it does become very clear that the label is important, and the natural tendency of people is to label things to sort of create shortcuts in their own mind. And the downside is that people then tend to judge and categorize those things that are labeled in a certain way. And if they're labeled incorrectly, they tend to judge them and categorize them falsely. In the context of heritage, Camila, maybe you could tell us a bit about how this technology, whether it's a rebranding of an old innovation or if it's something new for your field.
Well, actually, as I was mentioning in the introduction, I believe that the concept is more like a rebranded innovation, since I think that the idea in itself has the origins long before the term actually appeared. And as Mohammed also said, it is rather complicated to go to the deep understanding of the term. So maybe also because lately in the museums and in cultural heritage, especially with the pandemics, for example, the term of digital twins has actually advanced even more. So I think it's more of a rebranded innovation than a new term.
Okay. Mr. Lasse Berntsen, do you have anything to add from Norway on this?
Yes, actually the first time I experienced digital twins was in connection with the construction industry and building models. But what happened recently is that because of the low-cost entry into the IoT market, we are able to construct digital twins for a lot of different things. And buildings are large, they are complex, but what we do nowadays is also to make digital twins for simpler objects or systems. And this is what I see is happening right now, is that with the introduction of IoT, we can make a virtual model of physical objects and thereby enhance the functionality and the inner workings of these systems or objects. And maybe the most important thing is that this can give competitive advantage to the companies that actually make these digital twins because they can enhance their products in a way that benefits the customer. This is my input.
Thank you, Lasse. That will bring me on to the next question after Jean-Pierre has given his intervention on the subject of the definition of the term digital twin. Jean-Pierre?
Yes, for me, it's very difficult to define digital twins because I'm not really sure that what I do is really digital twins. Maybe it is not exactly the same problem that for other application domain. Generally, I think that digital twins are designed for professional in order to recreate something very near that the real things that they will have to manage. In my case, it's a model for students that simplify the real thing. So I'm not sure that it is really it's really digital, but it's not really a twin in my case. So for me, it's very difficult for me to give the definition or to give a context for digital twins, but I think that it is really open now, and maybe it should be more precise in the future.
Yeah, well, in fairness, somebody like me who's sort of a layman looking from the outside in, see the models, the 3D models that you've prepared or you work with your students. It does have all the hallmarks of a digital replication of reality, and it gives them the ability to manipulate and change systems in that represent electrical circuitry and whatnot in a safe manner. And from that perspective, it certainly adds value. And for me, it represents digital twinism. Be that as it may, now we can get on to the meat of the discussion. For our audience, please be aware that shortly, about 30 minutes into this discussion, I'm willing to field questions. You should just use the up hand functionality. And if you're unwilling to speak, you can just write a message to all, and then we will call out the question and put it to the panel. So be ready for that. I'm going to be a little bit selfish. One of the things that United Europe is interested in Europe is the competitiveness of Europe. And that's why I'm going to jump straight to the question on how can digital twins provide competitive advantage in the market? Can one of the panelists decide if they want to take that question first? Just show me your hand. No one brave? Do I have to designate somebody?
Yes, I raised the hand, but maybe you don't see it.
Go ahead, Lasse. Thank you.
So it's actually what I started to say in my last part was that it may give companies competitive advantage, and this is mainly because we are able to enhance the products in new ways. Let me give you some examples. When we have this new systems or objects, we can do software updates instead of only hardware updates that some of the products used to be. Remember, this is physical products mostly. We are talking about from cars to lawn movers to washing machines. And what we can do is that we can actually give upgrades through software, even if the hardware is the same, because we can improve the functionality. At the same time, we can provide new mechanisms for like doing predictive maintenance, which is very important. So instead of you having regular maintenance on the equipment is sending some information to the manufacturer when it needs some service, which reduces the need for maintenance. So it means that you can actually deliver a product that is better on cost or more cost effective related to maintenance. These are just some examples of competitive advantage that you can get from equipment with built-in IoT and the virtual model, because the virtual model represents what you have in the physical world. Yeah.
So it's a sort of a parallel to product lifecycle management. Yeah, that's very clear how that can help us in the market. All right, does anyone else want to jump in there? I see Mohammed is unmuted.
Yeah, I can do. I think, you know, in built environment, there could be lots of application for digital twin. Not only, you know, in terms of application, but also we can resolve problems that so far we haven't been able to resolve with existing methods. Take the example of building energy certifications. When, for example, you have a building, for example, using the LEED US certification scheme for, you know, as top rated, or the BREEAM or any other European energy certification scheme, what's happening when building goes into a real operation, they don't really perform as they were rated and designed. So if you monitor buildings using digital twin, whatever that means, let's forget that now, you would be able really to create new knowledge between about how the building perform and why it performed in such a way, and maybe give feedback to the energy certification system. So you can update the energy certification system. They become dynamic rather than static that stays the same for, I don't know, 10 years. That's at, you know, building level. At city level, there is lots of opportunities in terms of urban planning and, you know, planning any interventions, especially take the example of COVID. You know, what happened in COVID, lots of high street had to do street furniture, had to do alteration of their layout, new schemes. If you had a city that had digital twin enabled, you could have actually simulated those interventions rather than trial and error. So there is lots of money to be saved. There's lots of scenarios that can be simulated at building level and at city level. I think there are really exciting opportunities. It's just they need to be explored in a systematic way. The knowledge can also be transferred across Europe if there is a, you know, an institution or a body looking after digital twin in a very organized way, systematic way, defining use cases, defining things at strategic level, at application level. There could be lots of lessons as well to be transferred from countries to countries. We could identify the use cases that we need to focus on. We could identify principles for cybersecurity and so on. There are lots of lessons to be shared. There are lots of opportunities to be unlocked.
Thank you, Mohammed. And so what you're saying is when you have dynamic systems, you can model them in several iterations until you find the optimum way to, like the example you gave, the high street dining in cities. I mean, there are lots of components there. There are pedestrians, there are cyclists, there are motorists, there are different users of the street, different modes of transport on the street, and they have to be dealt with. And I guess if you try to do that in real life, it takes up a lot of time and a lot of delays, but you can model it excellently on digital twin and then implement it in real life. Olga, you were unmuted there during Mohammed's intervention. Maybe you want to go next on competition digital twins.
Oh, yeah, thanks. I think Mohammed already mentioned the simulation part, and I want to develop on this aspect because simulation is, if you try it out in a well-designed digital twin, you can, well, there is a lot of money that can be saved because you don't have to crash actual products or to use actual materials just to see how your new process will work or how your new materials will glue together or work together. So for this, for the testing of new processes, it's a very valuable artifact when it's being done well. Of course, also for policy, some kind of policies that need to be implemented into closed system, be it a smart city, be it a city quarter, or be it maybe just one business or enterprise. You can simulate if you have designed your system well and realistic enough. You can see how this policy requirements would act on your processes or your existing communication networks or your social networks. So it will save you a lot of frustration, money, and time, of course, with permission that you've done is your simulation well and you collected all the data. And well, there I have to talk about maybe as a more negative aspect, since data and the data exchange is crucial here. So to have a good digital twin. So as we see with automotive manufacturers, it all depends on standard data exchange. And this is actually something besides the correct system design and the correct system realization. This is very crucial to functioning and valuable digital twin, is to have some kind of data standards that can be used here.
Olga, would you be able to go on a little bit more about what you mean by data standards? I mean, that's something that potentially Europe the European Union could be helpful with. It. We have the internal market. We are trying to achieve standards across the market that are easy to mix and match and replicate across the market. You're talking about more regulation?
I won't. Well, I don't think that regulation will help just by itself. There should be some kind of understanding that exchanging data is actually a competitive advantage or may create a competitive advantage. This is really crucial for the cooperation of the SMEs, because there's a lot of SMEs involved in manufacturing business and automotive manufacturing, of course, and everybody, well, not everybody, but more or less the state of mind is it's my data and it costs a lot to develop it, which is true. So I won't give it away to some kind of manufacturer. I want to have some control over it. So they work on an open standard, but tweaking it a bit into a customized area, so that not everybody can use the data just like this. So I don't think the regulation will be a big push here, since a lot of standards already exist. It's a mindset, it's best practices, it's a collaboration, it's a lived collaboration, which is required here.
Well, that touches very much on something that we did in a panel event about 4 weeks ago. Actually, Professor Theo Lin from DCU, who's part of the organization of this event, was one of the participants in there, and the conclusion was for competitiveness, we do need to have more open innovation, and we do need to have a better mindset and the exchange of ideas and so on. My background is as a lawyer, and my tendency was in business when I was doing deals was to protect the intellectual property of the party I was representing, which is, you would say, my job. But that was a handbrake very often on breakthroughs, and that's something that there are a lot of movement on now. It's just an actual profession now, open innovation in companies to stimulate that sort of mindset and that way of thinking. And we certainly in United Europe agree that regulation is not the way to go. We need to work on the mindset and the attitude and the go-get-it kind of mentality to create that innovation. And digital twins is a way to share those data across the data standards you're talking about. So long may we see lots more of that. I'm just wondering if we want to move on to another question in our discussion, and follow on from that. Like, who wants to take on the question around what the challenges are in creating a digital twin which is actually sufficiently realistic to be useful? Pierre, you were a little bit skeptic that the models that you're working on, whether they could actually be labeled digital twin as such. But my reading of it was that actually your students have enough to work with to be able to safely go through iterations of electrical circuitry without being endangering their own safety.
Yes, in my case, the problem is the digital twins are quite indispensable for the formation. And in classical formation, again, electrical risk. Students and teachers are very stressed during the formation because there are in reality two solutions. They can work on a safe electrical cabinet, but in this case, there are no risk. And so the formation is not conform to reality. Or there is really a risk. And in this case, it's very difficult to train non-professional in this case, because they can really experiment dangerous situation. So in this case, digital twins, I mentioned that I was not sure that it was really a digital twins because our aim is not really to reproduce a real electrical cabinet. It is to reproduce the main dangerous part of this element with a model simplest than the real one. And so to allow the student to understand what is dangerous and to experiment by themselves, to take risk. It's important to take risk without having somebody telling them not to do this. They can test everything. They can be died at the end of the experiment. And it is in this way that that this tool is very important because they can be actor of that formation. It's very it's really the difference between classical formation on the electrical risk and this formation with digital twins. They can be independent during the formation. They can experiment by themselves. And it's really the most interesting aspect of this situation.
Thank you, Jean-Pierre. I'm also interested to learn about the challenges in creating a digital twin. I see that Lasse has his hand up. Lasse, over to you.
Yeah, I would just like to comment on this because I don't think this is a digital twin. If you have a digital twin, you will have a physical representation and a virtual representation that interacts with each other and not a simulation on its own. I would say this looks for me more like a virtual learning environment than a digital twin. For me, it is a very close connection between the physical system and the virtual representation, and they should interact all the time. Yeah.
Super. Who can give me a bit more on the difficulty in creating a digital twin that's sufficiently realistic to be useful?
Well, I could go again with my remarks about the right system design. So you have to define your scope. So what do you want to actually design or to model? That's what Jean-Pierre said before. You don't really know for sure that you put all the aspects in your model. So you don't know if it's really safe to call it a good tool for simulation, or did you forget something very crucial? So defining the scope and the stakeholders and the actors is crucial. That means not only human stakeholders and actors, but also all the machines, all the business partners, everyone who is involved, all the employees. And of course here, some of my other research hobbies about ethical aspects of business modeling comes to play. So who do you model, what do you model, and how do you consider the consumer here or the user? How do you create a user-centric model so you don't forget the actual employee who has to work with the machine later on, or who is delivering the input of the designed twin, or has to put up with the output of the designed twin. So it is really crucial not only to get all the relevant data and aspects on time and in full, but also to think about people who will be working with the artifact, being the twin or the actual system in real life afterwards.
Thank you, Olga. Who would like to follow up on that? And while you're thinking about who wants to follow up on it, we have one question from the audience. from Petre Dini. The question is basically, standardization is a difficult task to achieve. Data ownership is a fact. What action or decision and what body should speed up a crispier business case for a large-scale adoption of digital twins? My view on that is that we basically need a change in mindset, and it's a cultural thing rather than for some legislative body. But I'll let the panel take up that question after we've finished dealing with this one, which is around the difficulties and challenge of creating a digital twin which is sufficiently realistic to be useful. Camilla, do you want to jump in on that?
Yes, thank you. I was actually going to connect what Lasse said before, because from my point of view, it is really important for the physical and the virtual objects to be really connected. And also in cultural heritage, it is important that the virtual model actually, the digital twin actually raises curiosity, but does not replace the original object. So I actually believe this is really important for cultural heritage. And also, on the one hand, it should be realistic enough in order to be useful, which means that a lot of time and of course money and personnel should be involved in producing them. But on the other hand, they should be realistic enough to engage people. And here there's another issue that I want to raise, since it's very important, and that's inclusion. Which means that we should consider that these digital twins should be accessible also to an impaired person, because, be it a visitor or a worker on a field. And I do not refer to to severe impairments only, but also to aging people, for example, which should be able to access digital twins with equal opportunities. So here also in the realism, we should talk about engagement of other senses as well, not only of getting sight and hearing, but maybe also touch or other senses. This should be, I think, the evolution of digital twins.
Two excellent points, Camilla. I think there's two facts to it. So we're talking about accessibility for people of different physical and mental abilities, but we're also talking about access for people of different economic backgrounds, and it's two sides of the same coin. That could be something which would augment and make worse inequality in the future, and something that's a challenge that I guess we haven't considered. You know, on the one hand, if we have very high fidelity digital twins that you need very, very high-end hardware, the accessibility of that to researchers and people working in the field in less prosperous parts of the world is going to be limited. So a balance needs to be struck on that hand. And then on the other hand, you know, the high fidelity promoting or having the accessibility for people who are hard of hearing or who have problems with their sight needs to be taken into consideration. That's an excellent point, and maybe we'll come back to that later. Does anyone else want to touch on the point about the challenges of digital twins? Remember, people in the audience, from here on in, we are open to questions. Just type them in the chat function or put your hand up and ask them yourselves. You're more than welcome. Jean-Pierre, there's Lasse has his hand up. Go ahead, Lasse.
I would just like to give a short example of a digital twin, and I have a washing machine that has actually got a digital twin on the mobile phone. So I can remote control the washing machine. I can get messages about the current status, and it even signals when it's finished with the washing. So for me, it gives some advantage as a user because I don't have to watch it. I get informed when things are happening, and I can remote control it. So it does not need to be very complex systems that we are controlling. This is a good example of a household appliance. Thank you.
That's an excellent example, and it's something that I guess the comedians could have a field day about. I'm just thinking like my digital twin washing machine, does it wash my digital twin clothes, and do I end up going around like the Emperor's New Clothes with just digital clothes on, or like this digital background in the background here? That's my digital twin here. Excellent, thank you very much, Lasse. Does anyone else want to jump in on that, or there's nobody from the audience? We have a hand up here from Mohammed. Go ahead.
Yeah, I think, you know, there are a number of challenges for the diffusion, I would say, for digital twin rather than like one ad hoc application and development and research and development project or so on. One of the biggest challenges is really economic analysis and business models for digital twin. So far we lack feasibility studies and benefit evaluation models. We don't have a cost benefit analysis that shows you the benefits of digital twins. Like the example given by Lasse is, of course, it's a good one, but it's very specific. When you look at the built environment, you have data coming from human, you have data coming from physical objects, you have data coming from surrounding environment. So it becomes really complex to develop an evaluation model. Even when you have a clear specific use case. The other challenge is basically, because digital twin is not one off-the-shelf product, it is a combination of technologies. So it's really challenging to develop the operational requirement for a digital twin for a given use case and its maintenance over time. Add to this as well the challenges mentioned earlier by Camille, I think, about the data sensing, data analysis, and the value of data, and recognizing the value of data, and having semantic models that work for different data sets coming from different objects or physical products within the built environment. So there are really a number of technical and business process and business challenges that all interplay really.
Excellent. I'd like to jump on to another facet of this discussion, if I may. It's something that's personal to me. If anyone's objection, please put their hand up and we can move on to a different question. But I'm really interested in what Camilla has to say about how digital twins can be useful for conserving knowledge and artifacts for future generations. Up until now, more or less, we've been relying on archaeologists and artifacts that have been preserved through various different means in the physical world to learn about what our ancestors did and how they made music, or how they conducted ceremonies, they stored goods, or how they managed the funeral rites of their own dead. Camilla, maybe you can enlighten us a bit more on that aspect of the cultural value of digital twins.
Well, yes, I actually believe that they are really, really important, especially nowadays, because they contribute not only to conserve the actual artifacts, but also to to increase the levels of information, the layers of information that they offer on the objects. But there's also another aspect that needs to be considered, and that was raised by Olga before, that can be transferred also to cultural heritage, and that is the correctness of the data that is being transferred, of the knowledge that is being transferred. I believe that in this case, it is actually fundamental. Because only if we think, for an instance, about the numerous smoking photos, for example, of the Mona Lisa on the internet, we should do something to combat that and to have only the originals going forward. So this is a challenge that I believe digital twins bring about. Concerning cultural heritage and knowledge.
Well, could it be that the digital twin can always be created into a non-fungible token, and you have the original knowledgeable token which represents the original? But isn't it equally important that those memes and sort of like the Mona Lisa smoking are equally as part of our culture and to be passed on to future generations so they can appreciate not just the aesthetic aspects of our culture in these days, but also the humor, the satire, and so on? What do you think about that, Camilla?
Yes, I believe that actually they are important also because they can, as I said before, they can increase the layers of information. So they can also help people see some details that are not actually visible. So maybe this is a very important advantage of the digital twins also.
Olga, do you have any view on this aspect of digital twins?
Yes, of course, it's very important. And I have also found the aspect that Camilla mentioned about accessibility crucial because we can, well, not only simulate different aspects of accessibility using quite, well, less effort maybe, but we also can tweak our real thing or our real system for different needs. So it allows us a lot of freedom degrees that a physical system wouldn't allow us to do. So, but I also really appreciate the correctness aspect, of course, because this is what all about the optimization. So how accurate should it be? Should it be just all 2-3 functions that are modeled, or should it be the whole system? As Lasse said before, it's enough if I know when my washing machine stops, or do I really want to know how many turns it did in the last 15 minutes? So the question about correctness, being in balance with your needs, with your function, is really important here. And also one aspect I want to throw in is also the necessity of a digital twin, because, well, it's digital, it needs resources, it needs energy. So per se, if we can avoid it, maybe we should think about it. So being sustainable in building digital twins is an aspect that we have to keep in mind, as well as when we are building the physical systems as well.
Thank you, Olga. That's an excellent point. But aren't there two kind of aspects to that being sustainable? Yes, a digital representation of reality, it takes energy to represent it on the screen and transmit it across great distances and so on. And similarly, like cryptocurrencies, are one of the criticisms about them is the fact that they are a huge drain on resources, and they do represent a sort of a digital twin of money. I know there's a whole debate there that we won't get into now because they don't represent truly money as such, but they are a representation in a manner of speaking. On the flip side, to Mohammed's point earlier on, digital twin does allow for the creation and representation of reality and for the tweaking of the dynamic system, taking into account many of the variables in that dynamic system until a sort of an optimal result comes out, and it's you're more or less applicable in the real world, and then you can apply it, and by that you save energy, you save resources. You know, if you had to pour the concrete for a bridge 10 times to get it to exactly the right structure, that's going to be a lot more draining on our natural environment than if you were able to represent that bridge 10 times in a digital way and subject it to the theoretical stresses that the bridge is expected to support. I see that Lasse, you have your hand up. Do you want to jump in there?
Yeah, I just want to comment on sustainability. Some of my students worked on something called an irrigation unit for use in agriculture. And one of the important things about this is that able to detect when something goes wrong. And if something goes wrong, it means that a lot of water can be spilled and cause landslides and everything. Actually, the little energy we spend on the digital twin can actually save a lot of other problems in this context. I put a slide in the slide deck about this.
Thank you very much. We have some questions now from the audience here. I see from Suphiman Sufam Juneja, it's everybody there, but the washing machine, he's just asking the question whether or not digital twins are any ways different from the Internet of Things. There is many parallels, and that goes back to our discussion at the very beginning about the definition of the labels around digital twins, but we won't get into that. I have another one from Ioannis, the ability to share the technology and knowledge among diverse origin trainees that face limitations on accessing industrial infrastructure like marine workers, also for training on the job. That's more of a statement than a question. but it could be worth us jumping into that, because it goes back to what I think it was Camilla who pointed out, that access limited because of the physical and mental abilities of a trainee, for example, and also the economic abilities of it. How can we best optimize? Is there some way, some first principles that we can use to address those inequalities and maybe promote a standard that says that, okay, if you're going to do a digital twin, it should have this level of detail, this level of granularity to achieve access to the broadest audience, and then there's a sort of maybe a separate category for the high-end research. I really don't know where we should go with that, but certainly for publicly funded institutions, they perhaps need to bear in mind to have the accessibility of the broader majority of their students. Does anyone want to go back to that question?
Well, if I can, I will say that maybe a first step would be to have actually layered information, as I was saying, like in the case of museums, for visitors to be able to choose from basic knowledge to more advanced information. And I think this is the case in all domains, actually. So to help them have the opportunity to choose on how they receive information. And also not only on the ways of representation of this information, like written or audio or video, but also with the engagement of senses, as I was saying. I think this is important. And maybe from the economic point of view, it is also important to, since it is the digital divide that might get challenges from this point of view, I think it is important to actually learn first how to use the digital twin. So I think these are some aspects that might be a starting point.
Thank you very much, Amelia. Last, you have your hand up, please go ahead.
Yes, just a short comment on what Camilla said. And I think that in order to get accessibility, you should have some kind of dashboard. So you can get the overall, like for a building, you can see the building is in good condition, and then you can drill down by clicking on certain things, so you can get into the details, like for a single sensor in the building to find out what is happening there. So it's basically a way of making the software in a drill down matter, so you can focus on the detail if you want to, but if you don't want to, you will get an overview.
Thank you. That's an excellent suggestion. Olga, go ahead. You have your hand up.
Yes, thanks. It was about granularity of the designed information or presented information. It's a crucial question in business modeling, as you can imagine. So it's always a question about the scope and the goal. So who's going to use the model and why are you going to create the model? So these are two questions that should guide the reality granulation of your digital twin. So sometimes you need every detail of it, and sometimes you just need the main functions. And I think it also addresses the question about the digital divide, since the products that are made for markets with a lower bandwidth, Wi-Fi bandwidth, they do reduce their content, they do reduce media that they use. So the same goes for digital twins. Depends on what you need to show or to present using your digital twin, you should reduce the features that you want to model in accordance, of course, with the functionality that you want to show or to experiment with, but also in respect to the resources that your user or your customer has in his power.
Thank you very much, Olga. We've got just a few minutes left. We could maybe perhaps do a little round robin so you can prepare. Mohammed, I'll ask you first, but the question is, your own particular digital twin, or the project that is your favorite digital twin project. Can you tell us two things about it? Maybe how original you think it is, and if you were omnipotent, if you had all of the power in the world with no limitations, what would you do to make it better?
Yeah, I think one of the projects that's really exciting I'm currently involved in is Zarino, which is a Hedge 2020 project alongside Pier Angelo, who is attending here. What we are trying to do in that project, we are trying to develop a kind of digital twins that stitch together the design to the construction, actual physical construction, to the operation. So we'll be able to use all intelligence to predict the design solution. We'll build it as well in a very digitalized way. All performance of the construction site are modeled, but also visualized on dashboards and are interconnected. Similarly, the operation phase of the building, all performance of the building in terms of human-centered performance, how comfortable are the occupants of the building are also captured and as well broadcasted on a digital twin. And we'll be able to link the performance between predicted and actual performances. This is like quite really state-of-the-art, very ambitious, pushing the boundaries. And I say it's really ambitious because the divide between what we designers predict and what actually happen in real life, it's a very, very challenging area to fill the gap, but we are trying in this European project. If I had the power to, advance the digital twin world, I think the biggest challenge is the cost, because I listen to the human-centered conversation and I really like it, and sometimes I feel it's our ethical responsibility to hand over whatever we do, talking here from the built environment perspective, to hand over a built environment for the next generation that's not just on papers, that's really documented there. They can revise it, they can learn from our experiences. And the way forward to do it is really to have digital twin or a digital replica of our performances and building behavior, so they can really improve on it. It's like, when you sell a car, you give this building logs that include everything that happened in the car. We should be able to produce these things digitally and hand over our assets for future generation. That would be great if we can do that.
Super, thanks, Mohammed. We've got a few minutes left, so I really need to rush. Camelia, you want to just give us your aspect on how original your favorite digital twin project is, and if you had the superpower to improve it, what would that improvement be?
Well, yes, actually in my presentation, I brought the example of a digital twin that was used at the Louvre Museum and that regards the Mona Lisa. And that actually offers so much information on both the painting, the character of Mona Lisa, and so it augments the levels of information, and also it engages the visitors. But I think that, however, here there is a lack in accessibility issues, as I was saying, in engaging other senses. So this is what I would work on. Thank you.
Super. Jean-Pierre Toumazet, in a very few words, tell me, what would you do if you had the superpower? What would you improve in your digital twin? You need to unmute, Jean-Pierre.
Sorry. In my project, there is a robotic arm, which is just here like an illustration of the potentiality of the electrical cabinet. In the future, in the next future, we will interact with this robotic arm, and we have the material, the real robotic arm too, and so we will evolve to the real the digital twins here, with the interaction with the real element. So it's my dream.
Okay, super. That sounds really fascinating. Olga, very quickly over to you before we finish with Lasse and we do a wrap up.
My small project is about performance metrics of business processes in real life and in digital twins. And we are doing a model of a model, basically, and measuring how much effort we need to tweak the twin and to tweak the model. And if I had the superpower, I would really love to have empirical results from a real manufacturer to tweak the performance indicators there, and not only on the model.
Lasse? What's your
view? I don't need superpowers, but I have a dream, and we have a channel here in canal here in Norway called the Telemark Canal. It's about 105 kilometers and with 18 lock chambers. And the height difference is 72 meters. And we would really like to make a digital twin of this canal system. And we will actually have a meeting with them next month to see if we can realize that. That would be very, very interesting showcase. And also be of interest to tourists that are visiting the canal, because they can see everything that goes on. Thank you.
Super. I wish you all the best in that, and I hope that maybe if we have this conversation or the evolution of this conversation in a year's time, you'll be able to give us a positive update on that. That's it for today, folks. We're going to wrap up. I've just been asked to remind you that the booklet and a few pre-recorded panelist input are available for this discussion, as well as the live recording of this will be available on the EIRIA Digital World Programme site. Just to find out as well about United Europe, we are a non-profit association, and if you were willing and wish to support our work, you may do so. Just go to our website. It's posted here on the general chat function of the Zoom. It's www.united-europe.eu. That's united-europe.eu. Thank you, everybody. Thank you, Pietro Dini, Mohammed, Shokran, Kamil, Multumes, Olga, Levina, vielen Dank, Spatsiba Wamba, Jean-Pierre, merci beaucoup, and Lasse Bernsen, last but not least, Tusen Tak. Thank you, everybody.
Thank you.
Thank you.
Thanks.
Thank you.